Good morning, everyone, and welcome back to yet another lovely session where we are going to be learning about sensation versus perception and the ways in which we sense and perceive. My name is Professor Clarence Roberts, and I will be teaching you about the difference between perception and sensation. I am going to be contrasting between sensation and perception because they are two different terms. They are related, but they refer to two different processes in the brain. Before we begin, I am going to explain to you what sensation and perception is. Sensation, students, is the detection of a physical energy. For example, a mechanical energy, light particles or sound waves by our sense organs. And our different sense organs are, for example, our ears, our eyes, our skin, our nose, and our tongue, which relay this information to the brain, turning the signal to an electrical neuronal signal in the brain. Yes, indeed, it is quite amazing, my wonderful students. Perception is different because this is where the brain interprets the information gathered from sensation. Then it turns the information into an electrical signal and make it into meaningful experience. Students, it is very important for you to know the concept of transduction. And transduction is the process of converting external energy or substance into electrical activity in the neurons using a sense receptor. For example, cells in the back of your eyes that transduce light, cells in the part of the ear that transduce sound. Another very critical aspect of sensation, my students, is the sensory adaptation. For all senses, activation is greatest when first detect a stimulus. After the initial detection of the stimulus, activation will be decreased. Question: what does sensory adaptation reminds you of, my students? Did you say habituation? Oh, very good, Adam. Congratulations to you. That's correct. You're right. It's basically habituation applied to the realm of sensation and perception. Habituation states that you respond the greatest to stimulus upon first encounter with that stimulus. And over time, with repeated exposure of that stimulus, your response will tend to decrease. There has been a lot of studies that has gone into sensation and perception abilities. There is this whole field known as the psychometrics, looking at the ways in which we can sense and perceive, and so in terms of the limit of our perception, it is actually quite incredible. Here is an example of the absolute threshold. This is one metric for our sensation and perception abilities as human being. The absolute threshold is simply the lowest level of stimulus we can detect 50% of the time when no other stimuli are present. So, this is basically our ability to detect something at very, very low levels. And the question to you, my students, is what is the lowest level of stimulus that you can reliably detect? Again, 50% of the time. Well, it has been shown that on a clear night, you can detect a single candle burning 30 miles away. Again, students, we all can do that as humans 50% of the time, which will be our absolute threshold of light. It also has been shown with smell that the absolute threshold is 50 airborne particles, airborne molecules of a smell we can detect. So that's 50 airborne molecules or particles, which is very amazing because 50 molecule is not a lot of smells. Another metric apart from the absolute threshold is our perceptual ability, is the just a noticeable difference, my students, which is the smallest change in the intensity of a stimulus we can reliably detect. So students, can you notice the difference between an 80 decibel sound and an 81 decibel sound? And if you can, that's great, because that is just a noticeable difference, which is 1. Do you know that the Weber's law is a sort of application for these kinds of ideas? But it is also important to note, my students, that there is an observation that take it a step further. Weber's law stated that the stronger the stimulus, the bigger the change needed for a change in the stimulus intensity. To be noticeable, for example, a flashlight in the night will brighten up an entire room. But take that same flashlight out on a sunny day. What do you think will happen, students? It will not be so useful on a sunny day because there's strong stimulus, competing stimuli already in the environment. On a bright day, the addition of some light will not be so noticeable. The last concept that we're going to be doing in today's lesson, which is very interesting one, will be the multimodality or the multi-modes or the multiple senses. The principle which states that given the right circumstances, sensory system do not always stick to one sense. I am going to give you a lovely example. Have you ever rubbed your eyes with your hand? Your right eyes are closed, but you rub your eyes. Well, if you do that, you will notice that you produce the perception of light. So even though your eyes are closed and no light particles are entering your eyeball, but the sort of physical stimulus of your hands activate the sense receptors in the eye, giving light responses. This illustrates a multimodality, that you are getting a different sense, which is light, in response to touch, which is multi modes or multiple senses. It's always a pleasure having you, my wonderful students, to share this wonderful experience. And today's lesson, where we looked at the sensation versus perception lesson, was indeed a wonderful experience.